In exercise 18.4, we have to deal with a situation where there's uncertainty about the state of the world that will occur. An individual may happen to experience an accident or not. The individual has an initial wealth of $20,000. If he experiences an accident, he will suffer a loss of $10,000. If no accident happens, then his final wealth will be identical to his current wealth. And we have a number of sub-questions, A till C. We do them one by one, and it's always a good strategy to start with question A. And let's do that. And you need to know and note that this exercise has two pieces of information that are a little bit hidden. One piece is that the individual that we consider has a logarithmic utility function, and the second piece of information is that the insurance is competitively provided at actuarially fair rates. And these two pieces we need to use in order to get to a solution. And question A asks us to compute the outcome if the individual buys full insurance. So he is completely shielded from the negative consequences of the car accident, at least the monetary consequences of that. And he can buy this full insurance at fair rates, so the premium that he needs to pay is exactly identical to the expected loss he faces. And the expected loss he faces is, well, the loss is $10,000, which happens with probability 1/2. So the expected loss is equal to 1/2 times 10,000 is 5,000, and the premium, the fair premium to be shielded from this loss is identical to 5,000. And in that case, his utility will be, well, he starts out with an initial wealth of 2,000 or 20,000. Then he pays a premium identical to 5,000, so his final wealth is equal to 15,000. He has a logarithmic utility function, so the natural logarithm of a wealth of 15,000 is about 9.61. And that completes question A. In question B, we need to compute the outcome if the individual only buys partial insurance, which covers half of the loss. So the loss, if it happens, is still 10,000, but with partial insurance, which covers half of the loss, he will only get in that state of the world 5,000 from the insurance company. And again, the premium that he needs to pay for this partial insurance is a fair premium. And we need to show that the outcome that we computed in exercise A is preferred to the one that we will compute here. So I reiterate the outcome of exercise A to make the comparison easy. And the fair premium, so we first need to compute that for the partial insurance, because now only half of the loss is covered by the insurance policy. So only half of the 10,000 is 5,000. And to buy this partial insurance, well, the car accident will happen with probability 0.5. So the fair premium is equal to the expected loss is equal to 2,500. And now we need to again compute the expected utility of the individual. The expected utility is the probability of each of the possible states of the world times the wealth that the individual will have in that particular state of the world. So with probability 1/2, no accident will happen, but the individual has paid a premium of 2,500 out of his initial wealth of 20,000. So if no accident happens, his final wealth will be equal to 17,500. If an accident happens, which also happens with probability 1/2, his final wealth will be 12,500, being 20,000 he started out with, minus the premium of 2,500, and because only half of the loss is covered, the other half of 5,000 is not covered, so that also needs to be subtracted from the initial wealth. And that gives us 12,500, and if we do the computation, we end up with a number that's about equal to 9.60, which is less than the 9.61. So the individual will prefer full insurance over partial insurance. And that completes question B. Now question C offers a different perspective. So in question C we need to suppose that individuals who buy partial insurance rather than full insurance take more care when driving. And that may be the reason that they know that they take more care when driving. So they may also know that because of that they only need partial insurance. So, and if this is information that the insurance company also has, then these people will also be offered a lower premium. So if you buy partial insurance, then you are a safer driver and the damage of the loss is not 10,000 but only 7,000. So what would be the actuarially fair price of this partial policy, and what would the individual do? Would he now prefer partial insurance over full insurance? Now again, I post the utility from full insurance here again, and in this case, like in question A and B, we start with computing the fair premium, and the premium for fair insurance is the loss to which the individual is exposed is 7,000. In partial insurance, only half of the loss is covered by the partial insurance policy, and the probability that an accident will happen still is equal to 1/2. So the fair rate of the partial insurance in this case is equal to 1,750. So now we can do the computation for the expected utility again, and what we will have now is that in half of the cases no accident will happen. The individual will end up with a final wealth which is identical to his initial wealth of 20,000 minus the premium that he paid, so 18,250. And in the other half of the cases he will end up with 20,000 minus the fair partial insurance. But now a loss will also happen, and half of it is only covered, but the loss is not 10,000 but 7,000, and half of 7,000 is 3,500. So in this case, the individual out of his initial wealth not only needs to pay the premium for the insurance, but also out-of-pocket expenses of 3,500 for the part of the loss that is not covered. So he ends up with 14,750 in case of an accident, and summing the logarithms we get to a value of 9.70, which is not less but it's more than 9.61. So in this case partial insurance is preferred over full insurance. This is the final outcome, and that completes exercise 18.4.